Hey guys, so what we're going to do today is we're going to look at the different types of real world quadratic problems. So, in order to do this, we definitely needed to have the basic understanding of parabolas and graphing of them in order to do this today. So, what I want to do is follow along. These are all in your notes. I just want to make sure you understand these are really important pieces of information to have down when answering these questions. So, just know in real life, you can't have graphs in the negative realm. So you're going to make sure that when you're graphing that you start at your 0, 0, start at 0 on your X and then you end at 0 on your Y if possible. The other thing I want to make sure that you understand is that your graph and your table should always include the vertex because it's real life. Not all of them are always going to show up. So you may have to use the second trace button to calculate your vertex, whether it be your max or your min. The next thing you have to understand when you're looking at different keywords in the problem, certain keywords are associated with the roots and certain ones are associated with the vertex. So I want to make sure you guys understand those words. When you see them, that's what you're looking for. So when your question asks you anything about hitting the ground or reach or stopping or whatever, they're referring to your zeros, your roots, or your solutions. They all mean the same thing. The next thing, when your question asks you anything about reaching a maximum of any kind, or how far you are from the ground, or what's the highest height, or the farthest part from the ground, they're referring to your vertex. When you see the words average rate between two values, they're really just asking you to use the slope formula between those 2 points, and you can get that from the table. And the last thing, when they're asking you how far something has traveled, they're really referring to the horizontal distance traveled, not the parabolic distance or like how far it is in the arc, because that's more of a higher level math thing. All right, so what we're going to do is we're going to look at the first example, and then we're going to go to example number 9, and we're going to go through these together, okay? So you're going to have to pause this a lot to get these notes down. I'm going to have to kind of speed through this video a little bit because I can only get it 15 minutes to post to YouTube, okay? So a boy throws a ball, and the trajectory of the ball thrown can be described by this equation, where y is the height of the ball in feet, and x is the horizontal distance the ball has traveled in feet. Graph the parabola below. So what you're going to do, so you're going to go to y equals, you're going to plug in that equation, you're going to graph it. It's always a good idea to see what the graph looks like. You'll notice our graph goes off. So therefore, you might want to change your window. I'm going to say let's go up to about 20. Your y max. Your x's are okay. I'm going to change my window to 20 and graph it. Now, oh, look, so there we get a perfect parabola. So we know we want just the first quadrant, which is what they give us here. So we're going to start at our first 0 and then end at our second 0 and copy down those points. So you're going to go to your table, second graph, copy down the table. So I'm going to go from 0 to 7, but you'll notice that my vertex is missing, so I'm going to have to leave room for that. So copy that table down on your paper. You're going to go 0, 1, 2, 3, 4, 5, 6, 7. And then we're going to leave room for our vertex. You can even space it out if you want. That's fine as well. So we're going to do 0, 9, 15, 18, 18, 15, 9, and 0. And then we're going to look for our vertex. So how do we do that? Again, you know it's in between, so you can adjust your table to 0.5s or do second calc. I like using these buttons just to kind of navigate your calculator a little bit more. Go to maximum, and then I'm going to scroll over. I'm going to use the arrow. I'm going to scroll up, get my left bound. So I'm going to go to the left of the maximum, press enter. I'm going to go to my right of the maximum, press enter. Is this a good enough spot? Yes. And you'll see it's at 3.5 and 18.375. So that's our vertex, 3.5 at comma 18.375. So now we're going to graph it. So our XY, 0, 0, 1, 9, 2, 15, 3, 18, 4, 18, and then in the middle is 18.375. You're going to estimate that to the best of your ability. 5, 15, 6, 9, and 7, 0. You're going to connect it in a nice curve. You don't want a flat. And then you're going to write your equation y equals negative 1.5 x squared plus 10.5x. Now, you're going to encounter questions today that don't have x's. They have different letters. Just remember, when plugging it into the calculator, you always just use x. All right, so pause the video, make sure you get this down. Next spot, we're going to answer the questions, okay? So I just kept the table the way it has been. I have my parabola. Now, part B says determine the maximum height of the ball. Now, remember, maximum is just another fancy way of saying vertex. So you're going to go look for your vertex. So in your vertex, you have to remember the 3.5 represents the horizontal feet. They're looking for the maximum height, which is going to be your 18.375. How far will the ball be when it lands on the ground? Well, that's your horizontal distance again. So that means how far it's going to be from the boy when it lands on the ground, and that's going to be 7 over there. Because again, hits the ground is 0. So it'll be 7 feet from the boy. Okay, pause the video, make sure you get this down. Then we have D. It says the boy is trying to throw the ball over a fence. The fence is 20 feet tall and 5 feet from the boy. Will the ball make it over the fence? So what you're going to do is you're going to go to 5 feet from the boy. You're going to go up to 20. And looking at that trajectory, the path, would it reach over the fence? And your obvious answer is no. And then you could also look at the table. It's only going to be at 15 feet. It's at 5 feet away. So it won't reach over the fence. So it'll be no, because it will be at 15 feet high. All right, and then what's the average rate of change between 3 to 5 feet? So your next thing you're going to do is you're going to box off 3 to 5 feet. And those are the 2 points you're going to use to find your slope. So your slope formula is y2 minus y1 over x2 minus x1. So you're going to fill in, this will be 0.1, this will be 0.2. These are your y values. So you're going to do y2 is 15 minus 18 all over x2 is 5 minus 3. So you would get negative 3 over 2 is your average rate of change. Okay, pause this, make sure you get this down. And now let's move on to number 9 in the packet. So a lot of this is just interpreting, so make sure you know to get these tables down and make sure you can answer them. All right, so a baseball player throws a ball from the outfield towards home plate. The ball's height above the ground is modeled by this equation where y represents the height in feet, and x represents this time in seconds. The ball is initially thrown from a height of 6 feet, which is why we have that 6 there. How many seconds after the ball is thrown will it be 6 feet above the ground? Again, we're going to look for where y is equal to 6. That's what it means. And the maximum height of the ball it reaches, and that's going to be your vertex. So these are 2 questions that you're going to need to be able to answer, and you need to know where to look for these answers. You don't have to actually graph it, so you're just going to be getting a table down and interpreting it. So we're going to go back to y equals. We're going to clear out our equation from before, and we're going to type in negative 16x squared. Now remember I said your questions may not have x's. Just remember to just type all x's in when plugging it into the calculator. And then plus 6. We're going to go to our table. We're going to copy the table down. It starts at 0, 6, and then we have 1, 38, 2, 38, 6, 3, 6. And then if you notice, it goes right to 4, negative 58. So what that means is that when it touches the ground, is going to be somewhere between 3 and 4. Now, this is where you could use the quadratic formula to find it, or the calc function in your calculator. There's lots of different ways, but you'll start seeing we're going to go over algebraic ways to find these answers again, just to show you how that's applied. All right, so when will the ball hit 6 feet again? And that would be here after 3 seconds, because we're looking for where y was 6. And then your vertex. Now, you know your vertex somewhere in between there. So what you're going to need to do is, maybe we can show you how to adjust the table this time, because when you graph it, it goes off the graph. You can either adjust your window to above 38, because that's how high 38 is. Or let's just show you how to adjust the table and go by 0.5. So we're going to do second table set. So that's here. We have this blue button, table set is window. We're going to start the table at 0 and go by 0.5s. And then we're going to look at what it is at 1.5 because I know where that's where the vertex is. I know it because it's right between the 38s. If it wasn't 38, 38, then the vertex wouldn't be there. You'd have to use your calc button. So we have 1.5 and 42. So therefore, I know that the maximum height it's going to reach is 42 feet. Okay, so this is how you just use your table and your graphs to interpret real life quadratic problems. Pause the video and copy this down. Now what you're going to do is we did 2 examples together. I'm not going to do any more because you have all the foundation you need. I want you to try the next 4. Try these on your own using all the vocab words that we just talked about. When you're done, just send me a picture of your work. Remember, you could do your work on any paper. It could be any graph paper. It doesn't have to be the paper that I provided. Okay, and write out your work from there. If you have any questions, just message me.